1.2, compound interest future value. So in yesterday's lesson, or in lesson 1.1, we talked about simple interest. But what happens when it's compound interest? Now I know that we took down a formula, or we took down a definition for that, but let's just rewrite that. So compound interest is interest that is earned or paid. Now in this unit we're just talking about investments, but in the next unit we're going to be talking about borrowing money as well. So that is earned or paid on the principal plus the accumulated interest. So essentially what you're earning money on is, if I were to just draw this, this is your principal right here, okay? And you earn interest on that. But then, so this is after year one, but then that whole thing, this whole thing gets reinvested. And then the interest plus the principal becomes the new interest. And then interest is collected on top of that. So it's a little bit different from, say, something like simple interest, because essentially with the simple interest, the same amount of interest is being earned every single time. But with a compound interest, the interest that you earn gets reinvested, and more interest is collected there. So you can see how that can be pretty beneficial. And if you don't quite see that, don't worry. We're going to talk way more about that. So finding a future value of a compound interest investment uses the formula that can be derived, that's a fancy math term, from the simple interest formula. So it just means that we can build it from the simple interest formula. So, example number 1, Samantha earned $5,400 in overtime on a carpentry job. She invested the money in a 4-year Canada savings bond, which you know all about, that will earn 3.8%. What is the future value? Okay, not the interest, but the future value, which is our A, of Samantha's investment after 4 years if the interest is compounded annually. So that means every year, annually, the interest gets glommed on to that principal and gets reinvested. So let's just remind ourselves what future value, what the formula for future value is. So A, the future value, equals P plus PRT. Now this is for our simple interest, but remember we're going to be using our simple interest formula to derive the compound interest formula. Now, just letting you know, if you're not getting this next part, don't worry too much about it. This is just for, mostly for people who really like the math part of things and just want to know where all the formulas come from. So here we go. What I'm going to do is I'm going to factor out that P. Don't worry, we won't have a lot of factoring in this course. But if you can just follow me, factor out that P. So A equals P times, if I factor out the P from P, I get 1. Plus RT. It just makes it so that there's only one place to plug in P. And this is the one that we're going to use here. So, initially, Samantha has invested $5,400 or $5,400. So this is going to be our P. So after year 1, we have the future value here equals P, but we're not going to write P, we're going to write 5,400 times 1 plus R, which let's R, which is 3.8%, which is 0.038 in decimal form, times T. We're just going to figure out after 1 year, after the first payout. So when I get that, I get 5,400 times 1 plus 0.038 times 1, which is just 1.038. Oh. When I put that in my calculator, I get $5,605.20. Now I just wanna draw your attention to something. This is gonna sound really silly. Okay, 5,400 times 1.138 is 5605.20. Okay, I might feel silly right now, but you'll see where I'm going with this. What about year 2? We got a new principal in town because this is compounded interest. That means we take all the principal plus the interest and we reinvest it so that we get interest on interest. Cool. So A equals, we're going to be using this formula again, P times 1 plus RT. I'll just rewrite that. Now the new principal is the amount that's the amount after 1 year, so we get 5605.20. Don't worry about that dollar sign there, times 1 plus, the rate doesn't change, 0.038, and we're just going to look at it for 1 more year as well, so the time is just 1. So in this we get 5,605.20 times 1.038. Hold the phone though, guys, here. Look at this. What does $5,605.20 equal? It actually equals 54 times 1.138. So instead of $5,605.20, what I'm going to write is 5,400 times 1.038. But then, so I'm just going to highlight, the only thing that I substituted is here, because these two things, the pink highlights, are the exact same amount. But look at this, I have one extra 1.038. I'm just going to re-juggle this a little bit. I get 5,400 times 1.038 squared. So when we multiply these two things together, we get 5,818.20. Now I'm going to color this in a different color. I'm going to say that this one's green. Okay? And we're saying that the two green things equal the exact same thing. So 5,400 times 1.038 squared is 5,818.20. Let's just look at 1 more year. And I think you'll see the pattern. Year 3. Still using the same formula, A equals P, 1 plus RT. The new principal in town is 5,818.20 times, oh, I should change the bracket there, yeah. 1 plus 0.038, nothing's changing about that interest rate, times 1 year. So what we have here is 5,818.20 times 1.038. Hold the phone though, guys, because 5,818 is the same thing as 5,400 times 1.038 squared. So let's substitute that in. Okay, so the only thing that we did was we substituted in here. But look, we have one more, 1.038. So it's actually 5,400 times 1.038 to the 3. Year 3. Year 3. I bet you know what year 4 would look like. Year 4, A equals 5,400 times 1.038 to the power of 4. Year 4, 4. Now this is simple when we're just talking about annually compounding. It gets a little bit more tricky when we have to keep track of, say, something like compounding quarterly or compounding monthly. But that is in the next video.